If you're really not sure about the answer to a multiple choice question, you might still be able to eliminate some of the wrong answers so that you're more likely to select the one that gets you the mark. Watching this series of 6 videos should help you do just that. Let's get properties of matter started with this first question. A block has the dimensions shown. The block is placed so that one of the surfaces is in contact with a smooth tabletop. The weight of the block is 4.90 newtons. The minimum pressure exerted by the block on the tabletop is... So to calculate this, we use the equation pressure P is equal to force F over area A. The force is the weight of the block, which is constant, but the pressure will depend on which surface it's resting on. If this surface is in contact with the tabletop, then pressure will be at a maximum, since it's the surface with the smallest area. And as the area in contact decreases, the pressure increases. It's this surface that will result in the minimum pressure. As area increases, the pressure decreases. Substituting our values into the equation, we get a weight force of 4.90 newtons acting over an area of 0.2 times 0.1, resulting in a pressure of 245 pascals, which gives us answer B. Next up, it's a heat question. A solid substance is placed in an insulated flask and heated continuously with an immersion heater. The graph shows how the temperature of the substance in the flask changes in time. After 5 minutes, the substance is A. Solid, B. Liquid, C. Gas, D. Mixture of solid and liquid, or E. Mixture of liquid and gas. So we know that the substance is a solid to start with, and from 0 to 2 minutes, the temperature increases, which means that the solid is heating up. From 2 to 6 minutes, the temperature is constant, which means that the substance is experiencing a change of state. At this point, it's melting. At 6 minutes, the substance will all be liquid, and from 6 to 10 minutes, the liquid is heating up. We have another region of constant temperature from 10 to 30 minutes, which means another change of state. The liquid is boiling this time. From 30 minutes, it's a gas, which, as we move to the right, is heating up. If the substance is 100% solid at 2 minutes and 100% liquid at 6 minutes, then at 5 minutes it must be a mixture of solid and liquid. Our answer is D. Another question involving a change of state next, although it requires an equation. The minimum amount of energy required to change 0.5 kilograms of water at its boiling point to steam at the same temperature is... So to calculate the heat energy required to bring about a change in state in a substance at either its melting or boiling point, we use this equation. M is the mass in kilograms and L is specific latent heat, which has 2 values for each material. You'll find the values in the datasheet at the start of the exam paper. In it, one table gives values of the specific latent heat of fusion of various materials, where the value for water is 3.34 times 10 to the power of 5 joules per kilogram. This number tells us the energy required to change a kilogram of a substance at its melting point from solid to liquid, so it's not the number we need. The value we need is the specific latent heat of vaporization, which is given in another table. For water, it's 22.6 times 10 to the power of 5 joules per kilogram. This number tells us the energy required to change a kilogram of a substance at its boiling point from liquid to gas. So substituting our values into the equation gives 0.5 times 22.6 times 10 to the power of 5, which is 1,130,000 joules. Written in scientific notation to 3 significant figures, that's 1.13 times 10 to the power of 6 joules. D. Next up, we have a picture round. 5 students each carry out an experiment to determine the specific heat capacity of copper. The setup used by each student is shown. And here's the first one. The student with the setup that would allow the most accurate value for the specific heat capacity of copper to be determined is... So, student 1's setup looks pretty good. The immersion heater is placed fully inside the copper block, as is the thermometer. To be honest, this is my favourite so far. To calculate the specific heat capacity of copper, you need to use this equation, which can be rearranged like so. EH is the heat energy supplied, M is the mass of the block, and delta T is the block's change in temperature. Let's see if student 2's setup would give a more accurate value. The big difference here is that the copper block is now covered in insulation. This would cause less heat energy to be lost to the surrounding air, and as a result, the temperature of the block would have a greater rise than with student 1's setup. This would mean that the value student 2 would get for the specific heat capacity of copper would be lower than student 1's value. Student 2 would get the more accurate result, since more of the heat energy is absorbed by the copper block and less of it is lost to the surrounding air. What about student 3's setup? Not only is there no insulation, the immersion heater hasn't been fully inserted into the copper block. Because of this, lots of heat energy will be lost to the surrounding air, and the copper block will have a much lower change in temperature. The value of specific heat capacity will be too high. Student 4's setup is pretty easy to discount. No insulation placed around the copper block, and the thermometer is measuring the temperature of the air rather than the block itself. As for student 5's setup, they might have insulated the copper block, but that's not going to have any effect on the result since they're measuring the temperature of the air as well. To sum up, the setup which will give the most accurate value for the specific heat capacity of copper is student 2's, making the answer B. Well done, student 2. The next question shows the lengths we sometimes have to go to get just 1 mark in a multiple choice question. Remember that you can come back to questions that you're struggling with, because you might be able to pick up more marks elsewhere rather than struggling for too long for very little reward. The pressure of a fixed mass of gas is 6.0 times 10 to the power of 5 pascals. The temperature of the gas is 27 degrees Celsius and the volume of the gas is 2.5 meters cubed. The temperature of the gas increases to 54 degrees Celsius and the volume of the gas increases to 5.0 meters cubed. What's the new pressure of the gas? So the equation to use, as it appears in the relationship sheet, is this one. Pressure times volume divided by temperature is a constant. The reason we use this equation is that all 3 quantities are changing. If one of the quantities was unchanged, then we could use one of the other gas laws. To make use of this relationship though, we need to change it so that it resembles the other gas laws. Now there are lots of values given in the question, so it might be an idea to take note of them like this. The values on the left are initial values and the values on the right are final values. Let's see them as they're written in the question. The most important thing to note with this equation, as well as any other gas law that includes temperature, is that it only works if temperature is converted to Kelvin. To do that, we have to add 273 to the Celsius temperature. That makes initial temperature T1 equal to 27 plus 273, which is 300 Kelvin, and final temperature T2 equal to 54 plus 273, which is 327 Kelvin. Let's substitute all those values into our equation. This is going to take some rearranging, but we'll take it one step at a time. The first thing you could do is calculate the left-hand side of the equation. 6.0 times 10 to the power of 5 times 2.5 divided by 300. That works out as 5,000. Next, we could multiply both sides by 327. I could just divide both sides by 5 at this stage, but instead I'll calculate the left-hand side first, and then divide both sides by 5. If you're not very confident rearranging, then look out for the video I made on the topic and work through all the examples. So using a trusty calculator again, we can calculate the value of P2 as 1,635,000 divided by 5, which is 327,000 pascals. Written in scientific notation to 2 significant figures, that's 3.3 times 10 to the power of 5 pascals. So the answer is B. All that for 1 mark. If you've enjoyed watching this video half as much as I've enjoyed making it, then why not drop a like on it, and if you've not done so, subscribe to the channel as well. See you later.